Hey guys, we are continuing solving problems from Fundamentals of Physics by Halliday Resnick Walker. We are solving 8th edition. Remember the problems we are doing, you'll have same problems in your edition but with different numbers. Okay, with different numbers. This time we are solving problem number 21. Chapter 21, problem number 21. I'll just read out the question. In figure, particles 1 and 2 of charge Q1 equal to Q2 equal to plus 3.2 into 10 to the power minus 19. Q1 equals Q2 equals plus 3.2 into 10 to the power minus 19 coulomb. R on a y-axis at a distance d equal to 17 centimeter. From the origin. Particle 3 of charge Q3 equal to plus 6.4 into 10 to the power minus 19 coulomb is moved gradually along the x-axis from x equal to 0 to x equal to plus 5 centimeters. X equal to 0 to plus 5 centimeters. Plus 5. At what values of x will the magnitude of electrostatic force on the third particle from the other two particles be? Part A, minimum. Part B, maximum. And what are the minimum and maximum magnitudes? So we are given three particles, particle 1, particle 2 and particle 3. Particle 1 is positively charged and is fixed in place at a distance of d from the origin. Particle 2 is also positively charged and is fixed in place at the same distance as d from the origin. So particle 1 and 2 are symmetrically placed around x-axis. Okay, symmetrically around x-axis. Then you have particle 3 which is to be moved along this x-axis. So that means its position changes. And you have to move it from x equal to 0 to x equal to plus 5 centimeters. So particle 3 will be experiencing two forces from 1 and 2. We have to find out the net force and then we have to identify where that force is going to be minimum. At what position, at what value of x is that force going to be minimum? At what position is that force going to be maximum? And what is the value of that minimum force and what is the value of that maximum force within this range? Okay, within 0 to plus 5 centimeters, not beyond that. Within this range, we have to find out maximum and minimum values of the force and the locations and the positions where that force will be maximum and minimum. Okay, so we have particle 1 here, particle 2 here. Let's suppose particle 3 is at a distance of x from the origin. Okay, randomly taking any x. So we're not taking it within the range, we're just taking x generally. It can have any damn value. Okay, now this distance and this distance will be same because 1 and 2 are symmetrically placed. And what is that distance equal to? This is x, this is d. So you can use Pythagorean theorem for this triangle. This will be d square plus x square power 1 by 2 under root of d square plus x square. And this angle will be same, theta and theta, again symmetrically placed. Particle 1 will repel particle 3 since particle 3 is also positively charged. So force on 3 from 1 will be this way. F31, force on 3 from 1. And 2 will also repel it. So force is going to be this way. F32, force on 3 from 2. This angle and this angle are same, theta. This angle and this angle are same, theta, vertically opposed angles. Now these are the two forces particle 3 is experiencing. Let's resolve them. Okay, let's resolve them. This component of F32 will be F32 cos theta. And this component here will be F32 sin theta. Similarly, we will resolve F31. This component of F31 will be F31 cos theta. And this component here will be F31 sin theta. Now note one thing. Particle 1 and 2 are at same distances from particle 3. So distances are same. Charge values are also same. 1 and 2 are having the same values. So that means these two forces will be of the same magnitude. And obviously theta and theta are same. So F32 and F31 are same magnitude wise. Sin theta is same. So these two will cancel out. These two will balance out. So we're left with these two forces. F32 cos theta and F31 cos theta. So total force on particle 3 will be simply sum of these two forces. Okay, sum of these two forces. So let's find that now. So net force on particle 3 will be F31 cos theta plus F32 cos theta. F31 cos theta plus F32 cos theta. Sum of these two forces. Now F32 and F31 are identical, magnitude wise same. We're dealing with the magnitudes now. So magnitude wise they are same. So I can replace F32 by F31. So this will become F31 cos theta plus F31 cos theta twice F31 cos theta. Okay, twice F31 cos theta. So this implies F is equal twice gamma Q3 Q1 divided by distance between them squared. What is the distance between 1 and 3? Here, d square plus x square power 1 by 2. But we have to take square of the distance. So we have d square plus x square power 1 by 2 square of this distance. Then we have cos of theta. Now from the same diagram, cos of theta, you can see, we can use this right angle triangle here. Cos of theta is base divided by hypotenuse. The adjacent side divided by hypotenuse. So x divided by d square plus x square power 1 by 2. So x divided by d square plus x square power 1 by 2. So this implies F is equal to twice gamma Q1, Q3. I'll not use the values. I'll not substitute the values. I'll just keep them like this. X divided by, now here 2 and 2 will cancel out. Here 2 and 2 will cancel out. So d square plus x square power 1. D square plus x square power 1 by 2. Bases are same, powers are added. So we have d square plus x square power 1 plus 1 by 2 is 3 by 2. So this is our equation for the net force on particle 3. For any value of x. Okay, for any value of x. Ultimately, we have to talk about this range here, 0 to plus 5. But while deriving this equation, we are not considering any particular range for x. We are just considering any value of x. That x can be positive, negative, it can be greater than 5, less than 5, whatever. Now, this one is a special equation, comes many a times in physics problems. So, let's try to get something out of it. I'll consider special cases. Okay, I'll consider special cases. Number 1, at x equal to 0. So what will be the force on particle 3 if particle 3 is placed at the origin here? Particle 3 is placed at the origin. If x is 0, then everything becomes 0. So force is 0. F is equal to 0. Obviously, 0 is the minimum magnitude a force can have. Okay? So minimum force, we are already there. Minimum force is at x equal to 0 and that minimum force is equal to 0. Now that 0 value of x is within the range 0 to 5. Okay, that value of x is within the range. So this is one of the special cases when x is equal to 0. That means particle is at the origin. Net force on the particle is 0. Second one. If x is very small in comparison to d. Not equal to 0, but it is still having very small value in comparison to d. Okay, in comparison to d. So what we are doing here is we are moving this particle from the origin and moving it slowly away from the origin. But still x is small. Okay, still x is small. Particle is somewhere here. Particle is somewhere here. Still x is very small. So what will happen in that case? If x is very small in comparison to d, we can neglect this x. Okay, we can neglect this x. So what we are left with is f is equal to twice gamma q1 q3 twice gamma q1 q3 x divided by d square plus x square. Now this x is to be neglected. So we're left with d square power 3 by 2. 2 and 2 will cancel out, so d cube. We're left with d cube. You can clearly see force is directly proportional to x. So force is equal to 0. Where is it? Yeah. Force is equal to 0 at x equal to 0. Then when you move away from the origin, force will increase linearly. Okay, force will increase linearly. It's directly proportional to x. So starting from the origin, initially force will increase linearly. Okay, force will increase linearly. Now we'll see what happens when x is very large. Okay, when x is very large. So we have to consider now another special case. We consider 2. If x is equal to 0, then force is 0. If x is very small in comparison to d, that means we are moving from the origin little by little. A force happens to be directly proportional to x initially, not for large values of x, very small values of x. Force happens to be directly proportional to x. That would mean if we draw graph between force and x, initially graph will be a linear curve like this. Initially, later on it will change. Now let's consider another special case. If x is very large in comparison to d, not infinity, obviously at infinity force we know will be 0. X is now very large, so reverse of this one. We considered x small in comparison to d, and now we are considering x large, very large in comparison to d. Now if x is large in comparison to d, then we can neglect d. Okay, what will be our equation then? We have to neglect d now. So this will remain as it is, the numerator. In denominator, we'll have x square power 3 by 2. Again, 2 and 2 will cancel out, so we'll be left with x cube. Okay, we'll be left with x cube. And numerator as it is. So force in this case is equal to twice gamma q1 q3 x divided by x cube. 1x cancels out, so F is equal to twice gamma q1 q3 divided by x square. Meaning force is inversely proportional to x square. Same as that for a point charge. Okay, same as that of a point charge. So force is inversely proportional to x squared. So initially at 0, force is 0. Then force increases linearly. Okay, then later on when x is very large, force decreases as inverse square law. First it increases, then later on it decreases, so it must be maximum somewhere in between. Okay, maximum somewhere in between. Our graph for this equation is like this. I'll write here. F versus x. At x equal to 0, force is 0. Then it increases linearly, so we'll have a straight line. Then it decreases inversely, so it increases, reaches to maximum, then decreases inversely as x square. So somewhere here, force is maximum. Overall, we're not talking about the given range. Question asks us to find out maximum force within the range of 0 to 5 centimeters, plus 5 centimeters. We're not talking within this range here. Overall, we're talking overall, what is happening overall. So at this value, whatever the value of x, we don't know yet, force is going to be maximum. Up to this value of x, force is continuously increasing. Force is continuously increasing. So if this value of x here is less than 5, okay, less than 5, meaning 5 is somewhere here, then maximum force is here at this point. Whatever the position, whatever the value of maximum, we'll find that out. But if x, this value is greater than 5, okay, greater, meaning 5 is somewhere here. Well, in that case, if 5 is somewhere here, okay, we don't know yet where 5 is. We don't know yet. So I'm just considering if this happens to be this point where force is maximum, happens to be greater than 5, that means beyond our range, then 5 is somewhere here. and force will be maximum at that 5 centimeters. Because from 0 to 5 it is continuously increasing then. So if 5 is, this point here is greater than 5, then force is maximum at 5. If this point is less than 5, then force is maximum here in our range, within this range, force in whatever the value of x then. Overall force is maximum at this point. So what we'll do now is, we'll find out location, we'll find out the value of this x for which force is maximum. Okay, we already know what is the value, what is the minimum value for x, for force to be 0. We already know that. From the graph it is also clear. Minimum value of force is 0 at x equal to 0. So we are done with two parts actually. We are done with part A and part C. Part A asks you to find out the position of particle 3 where force is maximum. So that is 0. And what is the value? Part C tells you find out the value of that minimum force. Well, that minimum force is 0 at x equal to 0. Okay, so we already have answer for two of the parts of the question. Now we have to find out maximum. So what we'll do initially is, first I'll find out the value of x for which force is maximum, overall maximum force, not within our range. I'm not considering range yet. Overall, I'll find out position of the particle where force is maximum. Now, if force is maximum here, then slope is 0 at that point. If slope is 0, that means df by dx is equal to 0 at that point. Differentiation gives a slope. So slope is 0, that means differentiation of f with respect to x is 0. Okay, so that's what we'll use to find out the value of x here. So for force to be maximum, df by dx must be equal to 0. So let's use the value of x. d by dx of f is twice gamma q1 q3 into x divided by d square plus x square power 3 by 2. This must be equal to 0 now. Differentiation of this thing. Okay. Now this part comes out. Twice gamma q1 q3 comes out. Differentiation of this function. Now this is the quotient rule. We have to use quotient rule here. Numerator and denominator. So quotient rule, you must be aware of that. Quotient rule. Denominator as it is. D square plus x square power 3 by 2 as it is. Into differentiation of the numerator, that is x. Minus numerator as it is, which is x, into differentiation of the denominator, which is d square plus x square power 3 by 2, divided by denominator squared. So d square plus x square power 3 by 2 square becomes just cube. 2 and 2 will cancel out there. Now this thing is equal to 0. Okay, this thing is equal to 0. So this implies this part here will shift to this side, 0 will eat it up. This thing here will shift to this side, 0 will eat it up. So we're left with this part, numerator here. Okay, so we're left with this part here. Now let's solve that. D square plus x square power 3 by 2 into differentiation of x with respect to x is just 1. Then minus x remains as it is. Now differentiation of this thing, power 3 by 2. Okay. So this will be 3 by 2. Now you must be able to do this differential calculus. 3 by 2 d square plus x square power 3 by 2 minus 1, which is, I'll directly write. 3 by 2 minus 1 is 1 by 2. Then internal differentiation. Differentiation of d square is 0 and differentiation of x square is 2x. Now this thing is equal to 0. Okay, this thing is equal to 0. So this implies d square plus x square, d square plus x square in both terms. I'll take d square plus x square power 1 by 2. I'll take common. We'll be left with d square plus x square power 1. Now 1 by 2 plus 1 is back 3 by 2. Okay. We don't need to write it this way. I'll just erase this part here. So we're left with d square plus x square here. Then here minus. Now 2 and 2 cancels out. This is already out. So we're left with 3. X into x is x square is equal to 0. Now this thing will shift to this side. 0 will again eat it up. So we're left with d square minus 3 minus 1 is 2. So minus 2x square is equal to 0. Or 2x square is equal to d square. Or x square is equal to d square divided by 2. Or x is equal to plus minus d divided by root 2. So force will be maximums. See, we started with the condition that force is maximum. Only then df by dx is 0. So for force will be maximum at two positions, plus d by root 2 and minus d by root 2. Plus d by root 2 and minus d by root 2. That means plus d by root 2 when particle is placed on the positive side, d by root 2, and on the negative side. Okay, so there are two places where force is going to be maximum. So now we know the value of this x here. Okay, this x here. So we know it now. So this is here x equal to d divided by root 2. D divided by root 2. And d is already given to us. D is 17 centimeters. So 17 divided by root 2 happens to be, I have calculated that, 17, that is approximately 12 centimeters. So 12 centimeters. So maximum, overall force is maximum at x equal to 12 centimeters. But remember, we are asked to find maximum force within this range, 0 to 5 centimeters. So this value here, 12, is greater than 5. So meaning 5 is even less than here. So I'll erase this stuff now. So 5 is somewhere here. 5 is somewhere here. And force at 5 is here. Now look here, within this range, 0 to 5 centimeters, within this range, force is maximum at 5 centimeters. And overall force is maximum at 12 centimeters here, somewhere here. Now within this range, force is maximum at 5. You can see from 0 to 5, force continuously increases. So force is maximum here at 5 centimeters. Okay, so within our range, force is maximum at 5 centimeters. Now how do we find that maximum force? We have an equation here, so we'll use x equal to 5 centimeters here. Then let's substitute all the values and find out f. Okay, let's find out that. So within x equal to 0 to 5 centimeters, force is maximum at x equal to 5 centimeters plus 5 centimeters. 5 centimeters. And what is the value of that force? F is equal to twice gamma q1 q3 x divided by d square plus x square power 3 by 2. Let's substitute all the values with this x equal to 5 centimeters. That will give us maximum force within this range. Okay, maximum force within this range. So this implies F is equal to twice. Gamma is 9 into 10 to the power 9. Q1 is 3.2 into 10 to the power minus 19, and Q3 is 6.4 into 10 to the power minus 19. So what was it? 3.2 into 10 to the power minus 19, and the other one is 6.4 into 10 to the power minus 19. So Q1 and Q2. Q1 and Q3. X is 5. I'll not convert. We have centimeter length and length ratio of the two lengths. So there is no need to convert centimeter to meters. 5 divided by d, remember, was 17 square plus x is 5 square power 3 by 2. So you have to work out this thing here. I have already done that. I'll directly give you the value of force. It is 3.3 into 10 to the power minus 26 newtons. This is the maximum force within the range 0 to 5. Overall, this is not maximum. Overall maximum force is at x equal to, what was it, 12 centimeters. This is maximum force within 0 to 5 centimeter range. Okay, within 0 to 5 centimeter range. Is that fine? So let you take this as an assignment. You find out the maximum force, overall maximum force. This one here. Now you know the value of x. For that maximum force, for the force, overall maximum force, x is equal to 12 centimeters. So you just have to substitute x equal to 12 centimeters here and you will find the force, that maximum force. I'll leave that for you. So within 0 to 5 centimeters, force is maximum at 5 centimeters and the value of that maximum force is 3.3 into 10 to the power minus 26 newtons. Is that fine?